video we'll be solving this particular paper. You can see this is JNTU paper for very recent examination, June 2022, and we'll be solving this complete paper using AutoCAD. And I'll be doing this thing every year for JNTU because they'll be needing the answer keys for correction purpose. And okay, let's go ahead and see how to solve it out. There are a number of questions. There are a total of 6 questions, out of which the students are supposed to solve only 3. I suppose this is just the same Corona question paper pattern, which is supposed to actually be easy on the students, so that more number of students can actually pass, because they didn't get enough time to prepare for the examination. So it is understandable that the question paper would also be easier. Even though the other universities have shifted to the normal question paper pattern, I think the JNTU is keeping up with the older one. Anyway, let's stop the talk and go ahead and solve it out. So this is where I have copied all the questions from the paper, and I just have to do a little bit of tidying up to starting to solve it out. It's not actually 300, it says an angle 8 degrees. I don't know why can we paste it from the PDF. Every time degree is placed somewhere, it adds an extra 0 to it. Probably that's something to do with different font or formatting of the fonts. Okay, so here we go. So these are the 6 questions that we're supposed to solve. But I have to actually okay, gotta cut that off, place it in a new one. I'm gonna paste it. So each question I wanted to now separate text so that each of them could be actually separately solved. And right, the last one is this is the last one. There we go. So we have copied all the questions here in the iPad, and we are now ready to solve it. Apply the same formatting for all this text, and we're ready now to place it side by side. Two these questions could this is the last one. Okay. So let's go ahead and solve it out. Coming to the first question, we have a map. On this map, we have 2 points. Okay, so the distance between the 2 points is 1 centimeter. The real distance between them is 20 kilometers, and we have to draw a diagonal scale of this map to read kilometers and hectometers to measure up to 25 kilometers. All right, so there is a little bit of calculation involved here, so let me just open up a calculation bit, which I'll be doing in the SketchUp. Okay. I'm supposed to open a new file for this. And save it with my name. Alright. Engineering. I don't know anything on engineering graphics yet. Fine, so let's save it. And let's allow to delete all this. Alright. Something in red mode. This right. And I'll need to solve. Okay. What is it we need to solve? Let's see the question clearly. And okay. So what exactly is it we can solve? So 1 centimeter on the drawing is equivalent to 20 kilometers in the actuality. So this is the drawing size, the DS, the drawing size, and this here is the actual size. So using this input, we can actually find the value of RF. And RF, even though it's not been asked in the question, it's going to be better if I actually find it out. So RF is going to be the drawing size by actual size. So the drawing size here is 1 centimeters, and 1 centimeters can be written as centi is 10 power minus 2, and that's going to give us 8 meters. And we have 20 kilometers, and kilo we know is 10 power 3, and we get meters. The unit get cancelled, and we are just left with the RF value, and that's 2 into 10 power 4 plus 2, that is 6. So this here is our RF value, and next what we need to do is, using this RF value, we need to find how long we need to actually draw the scale. So the actual length of the scale is actually given to us, and that's turning out to be 25 kilometers. Oh, right. So this is one of those questions, and the question is really, really something really is wrong with this question, because if we take 1 centimeter as a small distance, no, that is representing 20 kilometers, and we're supposed to draw a maximum size of 25 kilometers, and with the diagonal scale we're supposed to show 17.6 kilometers on that. This is going to be very difficult to draw on the paper. It's almost not possible at all, because within a centimeter we need to actually not only make a number of divisions, but we'll also have to make scale. Let us see if we are able to actually make it drivable on the actual all right. So 25 kilometers is actual size, and we need to find the drawing size of this particular thing. We all know drawing size is actual size times the RF value. Let's go ahead, take it. 25 times 10 power 3, this is meters. The RF value we are going to get is 2 to the power 6. So we just cancel this. We just still left with 10 power 3 in the denominator. That's going to make it millimeter. So 25 by 2 millimeters. So that's going to be 2.5. So 12.5 millimeter is the actual length. Oh, come on. Can't be so. There's something wrong here then. Not, but there's definitely is something wrong here. Okay, let's cross verify it. 1 centimeter is representing 20 kilometers. You're supposed to draw maximum space for 25 kilometers. So that's just going to be a little more than 1 centimeter, which is exactly what we got. So here it's actually an mm. Fine. So 10 mm is the length for 20 kilometers, and we will have to actually draw 12.5 mm, represent a total length of 25 kilometers. Let's come back here. Use the AutoCAD commands now to draw this. So we are going to draw a length of 12.5 mm between 12 and 13. So you can see here that it is already very small length. This small amount of length, we're actually supposed to make all these divisions, and we're not only supposed to show kilometers, also we are supposed to show hectometers. And what exactly are hectometers? One hectometer is actually 10 power 2 of meter, and 1 kilometer we all know that is 10 power 3 meters. That means if you have something like 10 okay, so if you have a 10 hectometer, so that's going to be 10 hectometers, right? So 1 kilometer is actually be equal to 10 hectometers, and we're supposed to mark a length of 17.6 kilometers on that. Okay, so 0 to 25. If we make 5 divisions in this, make 5 equal divisions in this, we are going to get each division as equal to 5 kilometers, and then as well make 5 equal divisions in that each division, so to get 1 kilometer, and then that we need to further divide into 10 equal parts. So that's not that difficult, I guess. Let's go ahead and do the divisions. So I'm not going to go into details of dividing a line, so that you already know about it. And we are going to make 5 equal divisions. So now that we have 5 equal divisions, each of these division is actually uh, 5 kilometers. Each of these divisions is actually 5 kilometers. And now the next thing we have to do is much more difficult. This small division that we have here, we are really required to make 5 more divisions. So inside of this, we need 5 more divisions. Okay, before going for these 5 more divisions, let me just okay. So we're going to take 50 over here. Oh, come on. It's going like that. No idea. Something this. Oh, fine. So this is stylus. Right. So we're going to make 50 length. You can see already the big difference over here. We already got very small length. Already very small length. If you see the length of each division, that's 2.5 mm. And in this 2.5 mm, we are even asked to make 5 equal divisions. Then we are supposed to actually make a diagonal scale into this, which is crazy. This is not supposed to be the level of question asked for manual drafting. Even though if you're asking to this be made or like AutoCAD, using AutoCAD or some other such option, then that's okay. That's understandable. But doing that around here like this, that's crazy. Simply crazy. I think there is a spelling mistake here. There is a tapping mistake here, and this 1 centimeter is actually supposed to be 10 centimeters. This is supposed to be 10 centimeters, and if that is 10 centimeters, then a drawable kind of scale can actually be made. So I suggest this scale not to be used, and I'd like to recommend the 10 centimeters scale to be used. So I'm just going to add a few sentences here of my own to let the people who are doing the correction know about the mistake, and hopefully that they're going to listen to this mistake in question. Okay, 10 centimeter is misprinted 1 centimeter. Reason, the scale, the max length of scale according to printed question will be just how much I'm getting 12.5 mm or 1.25 centimeters, and making more deviations in this is not possible in manual drafting at least. This is an explanation. Probably, hopefully, they're going to listen to this, and this is probably the scale. That's the actual size of the scale according to the question that is given. That is not possible at all, as you can see. So let's draw the scale considering 10 centimeters. So if we consider this as 10 centimeters, then this is going to be multiplied at tenfold, so it's going to be 125 mm. 125 mm. So the total length of the scale is going to be 125 mm, and this we need to divide into 5 divisions. So 5 divisions in this. Now when we make 5 divisions in this, each of these divisions, the total length was actually representing 25 kilometers. When we made 5 divisions in them, each division actually represents a length of 5 kilometers. Now we need to subdivide it further. Okay, so subdivide this starting length further into more divisions. The that is complete the scale. We're going to take 50 mm of height. This way, we will need a vertical line at all these points, and we will need this point here connecting with the top left corner. So this is actually going to give us a diagonal. And then of course we'll have to draw a horizontal line at gaps of 5 mm. So we're going to take 10 equal divisions here. These 10 divisions are actually going to divide each smaller length over here into further smaller lengths. Now we just need to put the text. Yes, so this we're starting with 0 kilometers here. It's going to be located here exactly, and we'll have to take conversions around here. So this will represent 1 kilometer, so not 1 kilometer because each of that is 5 kilometers. 5 kilometers, so this is 10 kilometers, this is 15 kilometers, and this is 20 kilometers. Any length that we want in multiples of 5, we are going to be measuring it on the right side, and if there is less than 5, then that's going to be measured on the left side. Let's go ahead and see how we will actually solve it. So we will have to measure a distance of much. We are supposed to measure a distance of 17.6 kilometers. So this is going to be broken down into multiples of 5. So first we're going to take 15 kilometers on the right side. Then we will have to take some distance on the left side. The left side, each smaller division over here is going to represent 1 kilometers. So we have to add 2 on the left that way, and then we'll have to add 0.6 kilometers. So this we'll have to go for top. So this we have to go on the left side, this we have to go on the right side. So 15 on the right side, 2 on the left, and then 6 divisions on the upper direction. That's going to give us the exact distance. Let's go ahead and mark it over here. Okay, so this is 0, and 0 to 15. That's going to be exact 15. I'm going to go 2 divisions on the left. So on this line, we're supposed to go upwards now. 1, 2, 3, 4, 5, 6. So point is going to be here, and it's going to be from this point to this point. So these are the 2 points. So while showing it in the exam, of course, the students can actually show 2 alphabets. So one, let us say A, and the second over here, call it as B. Okay. So we can place 2 alphabets here, A and B, and then can just right here below AB. So AB equals what length is this? 7.6 kilometers. Okay, so this is the answer. This is one way to show it off, or you can just actually draw the dimension line between these 2 points, and you'd have to actually change this length to show the actual length of 0.6 kilometers. So this is how the solution to the problem is going to appear if we assume 10 centimeters as the drawing length instead of 1 centimeter that is given to us. So, right, so that's the solution to the first question. The first question. So, India always keeps making such mistakes. Okay, so let's go ahead and see what question next. Okay, right. Let's solve 2a questions. We have a major axis AB of an ellipse, that is that the length is given, with P as its midpoint. The foci f1 and f2 of the ellipses are 48 mm away from the midpoint P. Draw the ellipse and find the length of the minor. Alright, so this particular question doesn't have any, doesn't require any calculations to be made, so I'm going to put it over here right away. So I've been given the length of major axis AB, that's given as 140 mm. You just need to draw a horizontal line of 140 mm. Make sure it is at the center. Okay, and then we're supposed to take the midpoint of this. Let's go ahead and this is A. Okay. This point is A, then this point is B. So this is our major axis. Then the midpoint of this is going to be sorry, point just for reference. So it's supposed to take it at the midpoint. So midpoint? Yeah, that's here. Midpoint is P, and the major axis is AB. And we have been told the foci 1 and 2, f1 and f2, both are 48 mm away from the point. So from this point, we are going to take a measurement. We take an offset in this direction of 48, and in this direction as well. These points that we just got, these are the foci. F1, and this side, this is f2. These are the foci. Once we have the major axis and the focal length, we can easily find out the minor axis length. So actually we're supposed to draw some length over here. Then we know that the distance of this point to this point, the distance of the semi-major axis, will be same as the distance of one endpoint of the minor axis from the focus. So this is how this has now become the minor axis, because you can see I've drawn a circle with center at this point, passing through this point, and since the radius of the circle remains the same circle when I keep here, the distance of this center again from to this point on the circle will again remain the same. So that way we actually got the minor axis. When you are doing the manual drafting, you can just ensure to draw a small arc just to show that we had actually drawn the minor axis a little longer, and we were able to cut it right to this point. Then we have to draw horizontal lines passing through these 2 points, and vertical lines passing through both the ends. Now that we have a rectangle which is having not only the major axis and minor axis, we can easily continue to draw an ellipse inside of this. So the process to that is going to be very simple. We have to actually, now we might ignore the focus completely, and we need to make equal divisions in this length and this length. And this is actually going to help us draw the ellipse completely. Let's make divisions of now 40 means 70. So 5 divisions are going to be easily possible. So 70 by 5, each division we will get as 14. So let's go ahead and make 5 divisions over here, and this division as well. We will take 5 equal divisions over here. Let's actually, just to be sure the length of this line is, let's try to measure this minor axis. Not some decimal value. Okay. So we got to make take half of that here, and we got to make equal divisions. The same number of equal divisions that we make here has also been made. So we can take, you can see that I have made 5 equal divisions here. So all these points need to be joined here at the top, and these points, the points located here, they need to be joined with the bottom point over here. Okay. Once all these points are joined, we need to find the intersection between this and this. Okay, and then this and this intersect this and this. Okay, and then finally intersect these 2 points. Okay, so these intersection points are going to give us points which will be located on the ellipse. So the same diagram, same sequence, same steps we need to follow once again on the right side. We need to follow it on the right side. And then we'd have to actually take these measurements on the bottom side as well. So I'll not suggest you to draw these lines once again for the bottom part, but instead if you just take these lengths to the center, okay, the center, this point to this point, and if we just mirror them onto the lower side, mirror them this side. Okay, so whatever length is there on the upper side, same length we need to take here. So all these lengths are equal. So this length is equal to this length is equal to this. That way when you take all these lines, and same thing of course you need to repeat it on the right side. Okay, so I'm just going to take this. Okay, and thus we have got all the points which should be located in the ellipse. In fact, I can draw the ellipse using the command here. Now look at one endpoint, other endpoint, and here you can see this particular axis is passing through all the points that we just were able to define. So if there is some error, you can always refresh it, and it's going to update to show that it is exactly the same. While drawing it, of course, you will have to draw it with a smooth curve, and that's how it's going to be defined. Right, so this question solved. Let's go for the next one. And the next one is projection of with these projection of points. Let us see. So first, indeed, we need to draw the xy line, and we have a point P which is 15 mm above HP and 20 mm in front of VP. Another point Q is 25 mm behind VP and 40 mm below HP. So this is going to be in the fourth quadrant. As the first point that we got is going to be in the first quadrant. So this one is going to be in the third quadrant. Okay. To draw the projection of the point P and Q, keeping the distance between the projectors equal to 90 mm. Draw the straight lines joining their top views and their front views. So this is a problem basically for projection points, and there is a small twist here that the question is asking you to join the top views and the front views. We'll see how to do that. Let us start. So point here. And let me start here. So 15 mm above, so that means I have to take 15 mm above, and then 20 mm in front of VP, so the top view is going to go below XY. That's going to be 20 distance, and then we'll have to take the next point here. This point, this is a P point. Let's name is here. So this point here is the front view of P. So front view, we'll be marking it with a dash. Top view, we are going to mark it without. So we got both the front view and top view of this point P. And then we'll have to keep the distance between the end projectors as 90 mm. So let me take an offset from this at 90 mm. Then I'll have to draw the front and top view of the other point Q on this projector line. So that is 25 mm behind VP. So when it is behind VP, the top view is going to appear above the XY line. Okay, so the distance is 25. From here, the distance is 25. It's going to be that. And then 40 mm below HP. When it is below HP, the front view is going to be appearing below the XY line. So let me take an offset of 3, and this is going to be. So this is so what are the points we got? What are the points we got? So this point here is the top view of the point Q. This point here is the front view of the point Q. And now finally he is asking us to join the top views. So this is the top view of point P, and this is the top view of point Q. Coming to the front views, this is the front view of point P, and this is the front view of the point Q. So this is our solution. This is our solution to the problem. So this question you can see has been given for 15 marks, and it's such a small question. Whereas the other question given here, which is actually given for lesser marks, is got a lot of steps. But of course, to be able to solve this particular question, you will need to have a good visualization skill and also good knowledge, subject knowledge. Whereas here, you just need to follow some preset steps to finally arrive at the question. But the time taken for this lower diagram is much smaller. I think there should have been some justice made for the time taken for completing the diagram. Of course, you might argue that the students are going to take much longer time to actually come up with a solution to this. But then again, okay, let's just keep it 50-50. I would have been much more happier if same number of marks would have been given for both these questions. But okay, that's obviously not the case. Let's go for the next question here. So you're supposed to draw the projections of a rectangular hexagon. So this is a problem on planes of each side 25 mm, having one of its sides in the HP. So it's resting with its one of the sides in HP and inclined at 60. So it's got to be 60 degrees. So this is not 608, so it's got to be 60 degrees to VP. And its surface is making an angle of 45 degrees with HP. So the edge which is resting on HP, that edge itself is making 60 degrees to VP, and the surface is inclined at 45 degrees to HP. And one of the edges is of course resting on HP. So we are going to draw the hexagon in the top. Let us start drawing the hexagon in the top. So let me take XY plane. We will use the ready-made option of polygon here, and we're going to be using 6 edges. Right, so 6 edges, and we want to use the edge method to draw this. Each edge is 25 mm, so 25 mm. So this is my hexagon. So because it is having one of the edges in HP, I actually start drawing this above the XY plane. That means in the front view. Now, the surface is inclined with HP. The surface is inclined with HP. So this is actually right. So next we have to take project two lines and complete the front view. So this is the front. This is the front direction. Let's get the points. This is much more helpful if we make it. So this is the final thing we need. For the scale, of course, so we need to make a little dark. This one. So this need not be dark. So like this, right? So same way, when you are drawing the hexagon, this and this, these two, we need to make it so that you can all see this. Fine. So once that is done, we just need to give a naming here. So this is the top view. So let me start with A. Okay. Fine. A. I have C. Then we have B. Then we have E. And then we have. Now we're coming to the front projections of this. It's going to be A dash and B dash. And here this is going to be C dash and F dash. And here this is going to be D dash and E. Fine. So this here is our front view. So now we need to redraw the front view in such a way that the surface inclination with HP is going to be 45 degrees. So we do the same view, and we need to incline it 25 degrees. Okay. Now we need to project these points down, and find the intersection of that with these points. Okay. Right. This. So this point A and B. Okay. Then we just already find out points. This point over here. And these 2 points as well. I just have to extend this. Okay, so this is going to be the final. Let's make it dark. Let's put these names. Fine. So this one is going to be F. This one is going to be E. This is going to be B. This here is going to be C. All right. Now that we have the top view, we got to take the same top view, and without changing the surface inclination, we got to make this particular edge to be inclined at 60 degrees to VP. So I'll have to take and redraw this top view in such a way that this line is actually inclined at 60 degrees to VP instead of 90 degrees, which it is right now. So I'll have to rotate it. Well, let's say 30 degrees. We can rotate it this side or the opposite side, and based on which direction we rotate it into, accordingly we are going to take all of the points. So this is intersection between A and A dash. So this point here is going to be A dash. Okay, then we need to put this B point here, and this B dash is here. That's going to be intersecting here. So the point we get here is B dash. Next, let's go for C. So C is coming here, and it's coming here. So this point here is C dash. Now we need to take so from D here, and from D here, this is D dash. Integrating this. Okay. From E is intersecting here, so this is going to be E dash. And finally, we have F intersects here. So this here. F. Now that we have all the points, we just need to join them. So this. This is our final. Let as well extend this line a little. This. To write this point here y, this point here is x. Okay, and this then right here, this is VP, just below this. So this is how it's going to be. So this is the solution to question number 3. Let's go ahead and solve the question number 4. We have here because we're not going to need some space here. So we have a hexagonal prism. Side of the base is 30 mm long and the axis is 75 mm long. It has an edge of the base parallel to HP and inclined at 45. So this is not 450, this is 45 degrees. And because when I copy it from the PDF, the degree is actually converted into a 0, and that's why it's anyway. So so edge of the base is parallel to HP and inclined at 45 degrees to AP, and its axis is making an angle of 60 degrees with HP. We are supposed to draw the projections. All right. let's see how many angles are there. There are two angles. So edge of the base is parallel to HP. Instead of in HP, is going parallel to HP and it's inclined at 45 degrees to VP. So axis inclination, we're going to show axis inclination is with HP, so that's going to be coming up over above at the top. The inclination is going to be with HP, so it's going to be above XY lines. This is our XY line. Now we need to start drawing the hexagonal prism. So we need to start with the top view because the axis is inclined with HP. So inclination of the axis is going to be visible in the front view, and that's what we need to do first. So the top view, the hexagonal top view is going to be appearing below the XY line. But polygons, number of sides 6, and we want to use edge method. And what is the edge length? That is 30. This is actually a very big one, big diagram. I don't know whether it's going to be possible for the students to fit it within the given drawing sheet. The drawing sheet is large, and number of questions I need to solve of just 3. I guess it's very easy for you to fit this diagram on the sheet. Let's go ahead and solve it. So 30 mm side that we have done. I have to actually give naming to this. Name. So this is top view, so without dash we need to name all this. So C, B, E, and then next we need to draw the projectors. Not just the projectors, we need to actually draw the axis length as well. So this top length is 75. So this is going straight. This is going curve. Alright, so now because this is a prism, so there are going to be 2 points. There are going to be 2 points located at each of these corners. Let me just make that dark so that identify where the top view, where the edges, the projection of the edges are actually located. So okay, so each point, as I told, it's going to have 2 points. I'm just going to take the bottom point as A, the top point is 1, here will be 2, here C3, here will be 4, here will be 5, here will be 6. So the bottom points, I'm going to take it with alphabetic numbers. Okay. So let's go ahead and do the names here. So this point is at this point A and B both are going to overlap. So A dash first is going to be B dash. So B dash and A dash both are going to overlap here. And if you see it top, the points 2 and 1. So 2 dash, 1 dash, both are going to overlap here. In the middle here, we're going to get C dash and F dash. Now, however, we're going to get 3 and 6, 3 dash and 6. And here we are going to have D dash and E dash. Top we will have 4 dash and okay. So copy that here. Copy that over here. The name is also has to be here. Now you need to make the axis to be inclined at 45. No, axis is making 60 degrees with HP. Right now in this position, the axis is making 90 degrees with HP. So we need to change this 90 degrees so that it's going to be actually inclined at 60 degrees. I have to rotate it at this point in clockwise direction an angle of 30. Okay, so when I rotate it by 30 degrees, that's when I'll have angle of the axis with HP as 60 degrees. This is angle we need to be 60 degrees. Now I just need to draw the projections. here. Okay, so I need to now mark all the intersection points. Then I need to take this point as well. Okay. Mhm. Extend this two. Then I have extend them. Let's name all the points. So we have points starting here. Okay. And then we have points. Okay. Once you get all the points, we'll actually need to follow certain procedure to actually get all the visible edges and hidden edges. So we first need to draw the outermost boundary. So first we need to draw the outermost. This is our outermost boundary. Then we need to watch from the top. When you watch from the top, you can see that this particular face, this extended face, will be visible. So that is the face which we actually need to make it visible. Now that these edges are visible, when two edges are intersecting at an obtuse angle, the third edge from that corner will also be definitely visible. So we're just going to make this edge and this edge here visible. Then coming to finally the point, the hidden edges will be located like this. And then that has hidden edges, hidden edge formatting from here. Same over to this. So this edge, this edge, this edge, this edge. All those can be hidden edges. This here is prism. We actually had to name all the points as well. So let's start with this point. Okay, so this is A here. This is B. This here is C. This here is D. E, and this is F. Then coming to the top points, it actually starts here. So this is 1, this is 2, this here is 3, this is 4, this is 5, and this is 6. So now that we got all the points, all the visible edges as well as hidden edges, we need to make the edge which is resting on HP to be inclined at 45 degrees to BP. We have to extend this line over here. This down because we're going to need some more space. Next, we have to redraw this such that this edge here, which is resting on HP, is going to be inclined at 45 degrees to copy it first, and we need to redraw it in such a way that this angle is on 45 degrees. So it could be this side, or it could be the other side. Fine. I'm just going to provide you solutions to both the possible solutions. Do the inclination in negative direction. First, I will take copy this. Move, copy this, and rotate it in negative 45 degrees. So this is positive 45. This is negative 45. And for both these positions, I'll just show you how to draw a different view. Let us start with the points D and E, which are located on the XY line. So this and so this point here is E dash. This point here is going to be E dash. Fine. So similarly, we have to find all the other points, and once we find all the other points, then we have to actually start So I'll make it once again. So take this line here, this line here. So let's go ahead and take all the remaining points. So C is going to come and intersect this the same way F is going to come and intersect this. Then the other 2 points A and B, they are going to be from here. So if this is a point with this point, this is point F. This point here is C dash, and this point here is A dash. This point here is B. Now we got other points of the lower face. We need to continue to find other points at the top. So we got to continue with 1 and 2. 1 and 2 is here. From 1 and from 2, the lines are going to intersect here. And we got to take from 3 and 6. Let's go ahead and take 3 and 6. 3 is here. 6 is here. And then okay. So the positions are going to be placed the same way. So let's make copy it over to this place. Okay. And instead of A, B, C, and D, we're going to have 1, 3, 4. Plus, these are all going to have dashes. And then dash and 6. Plus, this is going to be 1 dash. Now that we have all the points, we just need to be able to join them. While joining, I had told you to be careful. You got to be joining them very carefully. So first, we just need to join all the outermost boundary. So E dash, E dash, where is E dash? E dash is actually here. Right? Here. E dash is here, and from there it's going to come here to here. Point, and then this here is outermost boundary. This here is outermost boundary. This is outermost boundary, and when we see from the left side, you can see the bottom face, bottom hexagonal face is going to be completely visible. So with this edge, we'll have to and because this is going to be visible like this, then just as I told, if two visible edges are intersecting into an obtuse angle, and the third edge appearing from that corner will also be visible. So next we got to draw the hidden edges. Okay, so hidden edges like, here. And we're going to do 2 more hidden edges. This to this point. Make those edges hidden. So this is how our diagrams will appear in case we draw it with. But what if it rotates in the opposite direction? Since we were here at the bottom side, then instead of the bottom face being visible, the top face is actually going to be visible to us. Top face is actually going to be visible to us. Even though the relative positions, of all these points are actually going to be the same, um, the naming, I guess, is very different, and the visible edges are actually going to come through this, and these edges will be actually as well. This is the final view when we rotate it in the other direction. With the top view, the other direction from what we rotated in the earlier step. I don't know. I get a lot of sleep. I never go to the screen for too long, and especially when there's a lot of white screen, white background screen. Okay, right, there are only two more problems. The last one problem I've already solved it a number of times. And, just going to skip that particular question. So I'm just going to solve this particular. So cube of 50 mm long edges is resting on HP with a vertical face around 30 degrees to VP. It is cut by a section plane. So this is a section plane perpendicular to the VP. Okay, so let's first place the cube properly, and for that, use this particular thing. So the cube of 50 mm long is resting on HP with a vertical face 30 degrees to VP. So we'll have to take it. So this is problem number 5. So this is, let us say, XY line. So one of the vertical faces is at 30 degrees. So we got to start drawing this at 30 degrees. We actually need to complete this square. And after completing the square, we just need to take projection lines. And these projection lines are going to give us the curve in. So this height, let us say, this is outermost boundary again. And this edge is going to be visible, so this is going to be dark. Then this edge here is going to be green. So this is the front view. Then it is cut by a section plane perpendicular to VP and 30 degrees to HP, passing through a point on the axis 35 mm above the HP. So first we'll have to take the axis. We'll have to take the axis. I'll deal with this point. Okay, so this is my center point, center of the axis line. And need to take so somewhere on this, let us say it is 38 mm, 38 mm, 8 above on the axis. The axis 38 mm above XP. Sectional views. So say the sectional view is this. We need to draw this sectional plane, and we need to remove this part. Remove. Then we need to draw the section top view and else sectional top view, two shapes in section, which we will get over here, perpendicular, not perpendicular, and move the lens. And development of the surface are the remaining portions. So development as well, we need to draw for this. As I told, the white background on the monitor screen. Anyway, let's come back to the question that we're supposed to solve. Then take a line, and I'm going to need to draw the polygons. The number of sides of 4 edges. Edge method is what I'm going to use. And okay, so I need to use the polar option over here, and like angle of 30 degrees. This angle is 30 degrees to x. In this particular direction, I need to take length of 50. This here is the top view. Then we need to go front view, so for the projection line, here, so it's straight, and here, and here. Okay, let me go into this. Okay. There's one more edge right here. That edge will be like this. There, it's going to be this edge, which is hidden. Now I need to take the axis line for axis line, of course, how to draw the diagonals, and the intersection of this will give us the axis. On this axis, I need to take the distance of 38 from the bottom line. So this is my point. This is my point. This on this point, I need to draw the section the same color. Rotate it in this direction by what angle? What is the angle at which it has been cut? Yeah, so both angles are 30 degrees, so this is again going to be 30 degrees over here. You could take 30 degrees on this side or 30 degrees onto the other side. So I'm just going to avoid on the other side. Take one side. Now this is my cut section, and all these top lines are going to just go away. Just here, just vanish. All these edges go away, and we're going to get another edge over here. So for this, we need to draw perpendicular lines. For this points, and take this, this, and then from this point I need to mark same lengths that your top. Okay, first let's go ahead and draw the section of top view. This line is going straight here. The lines are now intersecting. So here, here, because this section is not cutting to the bottom edge, so this complete edge is going to remain like this, and then we need to hatch this. Construction lines that I drawn earlier, and then we need to draw the true shape. This over here. I need to take that length from this point. Then these two edges are going to be full, so we're going to need then this one pass over here. So this up here, and over here got 2 points. This here, this. Both these measurements we need to transfer. We extend this point here. Right. So the true shape is the intersection of all these points. Start here. This what I got here is the true shape. And okay, so that is the true shape. If not done the naming, you can just go ahead and do the naming yourself. Then this follows follow. Solution to the final problem. I guess I have already done it. And let's just move. This file is going to take some time to open. Yep, it's taking time to open. Oh, come on. All right. So the isometric diagrams located here. I guess I've already said that. And off search for that tab. Okay, come on. Come on. Turns out I'm not doing that. Is it? But it's this side. Mm-hmm. I think I've not done that. I've done it several times, but I guess I've kept it somewhere else. Right, so let's go ahead and do it again. Let's come back to the problem. On one side, the diagram that we're supposed to draw and start. Right, so let again draw the XY plane, XY line. This time I'm going to start with front view is going to be on the right side. Vertically up, so we say 5. Then this side. And then 25. And then 25 for the bottom. 33 distance from both the sides. Then this edge here at the bottom, that's at a height of 6, 9. Right, so in the middle here it's going to be visible. On this side, it's not visible. Go ahead and all edges visible. They're going to be hidden edges as well. So edge, this edge, they're not going to be visible. So our front view already. We just need to start it from the top. Two, 19, and then 35. All these are the visible edges. And now we will take these edges will be hidden. So now that the top view is also ready, just switch on one last view, that is the side view. For the side view, we'll have to pull this for the X1 by 1 line here. This is where we need to start. Okay. Dark. This is visible. This edge here is going to go. And, okay, so this is going to go up and down. This, and only up to this point. Then okay. Yeah, so that's it. This completes the solution to this whole question paper. And I'll probably be solving one more so that I'll be able to do it so slowly like explaining. Just doing it fast track method. And I was showing that as well. But I think I'll be taking a little bit of care because I literally feel very sleepy myself, way more tired. So we'll stop here. See you till the next one. Bye.